In this first example, it wants you to move triangle OBA onto ORG. So it's going to be the big one onto the small one. You are going to rotate this about O, 90 degrees positive, and then you can tell that you are going to dilate it up about the center O by 1/2. Anytime you have shapes that are not near each other, you want to translate them to get them touching. This is the first one we've done in 2 days where they're not even touching at all. So I'm taking ETHP and I'm going to translate it over 8 up 0. So translate 8, 0. And then I'm going to dilate it. This one's a little bit bigger. You can tell by the bottom that this is 2 and that's 6. So we're actually dilating by the origin scale factor 3. Question 1 is very similar to a couple of the different questions in the notes from today. Name the similarity transformations and what makes them different from the isometric or rigid motion transformations. The similarity transformations are dilation, rotation, reflection, translation. And what makes them different from isometric rigid motion transformations is that that list includes dilation. That's the only difference in those two lists. Question 2 says, why are the rigid motion transformations part of the similarity transformations? Because anytime you reflect, translate, or rotate, you're really also dilating by 1. Talked about in class today. So it's still actually, when you're congruent, you're always similar as well. All right, some true-false questions. The first one, similarity transformations are all rigid motions. No, because a dilation is a similarity transformation, and that is not a rigid motion. Rotation is a similarity transformation. Yes, because all rigid motions are also similarity. C, all transformations are rigid. No, because dilation is a type of transformation, and that is not rigid. D, dilation is a non-rigid motion transformation. True. Stretch is not a similarity transformation. True. Because it has to be proportional, and stretches are not proportional. All right, these are the fun ones. Angle H would be in the same position as angle G. All right, the angles are pretty easy. And then we start the pattern game here. dr over AF. dr over AF. So it's these two, and then we go DH, so we go AG. Angle D is in the same position as angle A. And the last part here, AG, DH. AG, DH. Oops. And then something RH. It must have been FG. A little bit neater there, FG. On this irregular pentagon, I'm going to feel way more comfortable if I have them pointing in the same direction. So I'm going to take one of these and turn it so it's sitting the same way as the other one is. And like we said before, angles are pretty easy. Angle C is in the same location as angle M. And then we have AB over RY. AB, RY, ED, TM. See the pattern there? And the next one, MN, RT. MN, RT would be the same thing as CD, AE. CD, AE. Again, check for the pattern there. Angle T, right here, is in the same position as angle E. And you can see it here as well, T and E. Okay, now we have this next one, NT, DE. NT, DE, RT, AE. Follow what I did there. And the final one, AB over BC. AB, ABC are Y, Y, M. Are Y, Y, M. In number 6, it says that ABC is similar to another triangle, so we're looking for the second triangle that it's similar to write the similarity statement. It gives us this weird piece of information here. You don't even really need to draw the picture. You could figure it out, because if one triangle is ABC, you have A, B, C. So the other triangle must be this, this, this. A, B, C, boom, boom, boom. You could do this with patty paper, but I just redrew this one over here. And it is facing the other way, which is a reflection, but that's going to be easy to figure out. If I go G, Y, K, M, R, that would be like going G, Y, K, M, R. So orientation goes the other way, so it would be A, E, D, C, B. A, E, D, C, B. Instead of going this way, I just reflect and go that way. This one's quite a bit more straightforward because they're sitting in the same order. JMT would be the same as this, this, this. And this final one is just another reflection over that line. So if I was going to go BAC, I would reverse it and go this, this, this.